Okay. Let's continue. Any like question so far, or comment, or anything? No. Okay. Then let's continue. So there was this comment that it could be a problem that you have these tracing tools and you just use these APIs, and these APIs are baked into your code base, which is good for me, like I said, for my job security, but people don't really want to do this. And for this, there is an open source project called OpenTelemetry, which aims to solve exactly this problem. So I showed you these APIs. They basically have an API which is vendor independent. That's the goal here. This is there were two other projects called Open Tracing and Open Census. Does anyone know about this? Like heard about this? No. Open Tracing a little bit. Okay. Yeah. So these basically they merged, and they the two merged, and then those became OpenTelemetry. These two, like Open Tracing and Open Census, those are kind of the competing libraries or competing projects. Basically, the idea was having an API for tracing. That was basically the idea. Like fun fact, none of those reached version 1.2. So these were like 0 point something and already died. But now we have OpenTelemetry. So that's the next one. This is a CNCF project. So the Cloud Native Foundation is so that's behind that basically. It's super early stage, so everything I showed you in the first section, that's ready for production. So you can use those, and if there is a bug, then those get fixed. But basically, it should be stable. The OpenTelemetry is not yet stable, so it's still like 0 point something version. And that's basically a unified set of libraries and the specification for observability telemetry. That's it. And the goal is to avoid vendor locking, and basically they give you a library for .NET, for example. You can do your tracing with that, and you can output that trace wherever you want. If you want to put that into application insights, you can do that. If you want to put that into New Relic, you can do that. If you want to put that into Elastic APM, you can, not yet, but we plan to have that. So that's basically the idea. This is the architecture. This is a super pluggable architecture. So first of all, you have the, let me use the pen. No, the laser pointer. So basically, these are the applications that you want to monitor. And what you can do is that you can put an open, there are basically multiple ways to use it. Either you just add a NuGet package to your .NET application, as we did before, and then you can point that NuGet package and say, send all these data to an OpenTelemetry collector. The OpenTelemetry collector can either run directly on the machine where your application is running, or it can run on another machine, and you can configure this OpenTelemetry collector to output the data wherever you want. It could be Jaeger, Zipkin, Prometheus, Elastic, or whatever you want. Application Insights also has this. There is also another option where you just use the NuGet package and you say, send this directly to Application Insights, or send this directly to whatever. So you don't necessarily need this OpenTelemetry collector, but the big advantage with this OpenTelemetry collector is that you can even replace your telemetry, the stuff where you send the telemetry on the fly. So it's like, not only that you need to recompile if you want to use Elastic instead of Application Insights, you can do that without restarting your application. You just reconfigure that in the OpenTelemetry collector. We won't look at this OpenTelemetry collector in the sample application. So I will show you a quick demo which will directly talk to a telemetry collector stuff. So that's the OpenTelemetry architecture. There is in this demo that I'm going to show you in a couple of minutes. In that demo, we are going to use Jaeger. Who knows what Jaeger is? No one.
translation or
Sorry?
the translation of the word?
No, not like the software.
The drink?
So Jaeger is I think it's from Uber. It's basically a tracing system, but it does not really. It doesn't collect you for everything. It can take the traces and it visualizes for you. And this is an open source project, so everyone can use it for free. So what we are going to do here is that we are going to use the OpenTelemetry library and point all the data to Jaeger. So Jaeger is like basically yet another way to visualize these traces. One comment I would like to make here is that I already showed you application insights and Elastic, and those are like real observability tools. Like you can, like you said, you see, like you saw that before, you can visualize like metrics, logs, and traces and whatever. Jaeger is really focused on tracing, so you can show traces, but it's not about like full-blown observability with metrics and logs and stuff like that. Okay, so let's take a look at the. Is it that's too small, right? Is that's too small? Yeah, let's take a look at that in Jira Studio. So let's take a look at how this OpenTelemetry stuff works. So there is a specification for this, which is language independent. So it has nothing to do with .NET or whatever. It basically tells you what is a span, how do they work, and it also defines how to propagate the traces. For example, it also uses the W3C standard that I introduced you before. And the key point here is that there is one project. Let me go to Nuga.org, and if we go to OpenTelemetry, there is an OpenTelemetry API. So first of all, like I said, this is vendor independent. So this is done by multiple companies. This is completely open source, and this is on GitHub. And there is this API that basically gives you the opportunity to start the traces, stop the traces, and basically do the collection. And there are so-called exporters. For example, there is this exporter for application insights. You can use the API in a library, and it will be, by default, it will be a no API. It doesn't do anything. And if you use that API in a real-world application, you can just pick up an exporter, configure OpenTelemetry, and say, output that to application insight, or output that into Jaeger. So let's take a look at how this works. So first of all, you need imagine that this part is the library itself, and there is this tracer factory, and with that you get a tracer. And with this tracer, you can start a span. As you can see, they have a different syntax. So like I showed you what we have in Elastic API, for example. They have this using block. This is very typical. The open tracing C# API was very similar. So when the end of the using block is reached, they basically end the span. So there is a span.end method, but you don't have to call it because if you put that into a using block, they will close it for you. Stuff like that. So it's different, but the idea is the same. You start the span, and then it will be stopped at some point, and you measure the duration. And in the do-work method, we just get the same tracer. This is going to be the same tracer, and then we start another span. There are also ways to add, for example, attributes to the span, so you can store any arbitrary data. And so this is the library part. And then if you use that in a real application, then this is where you configure your tracer factory. And here I'm basically saying, okay, send this to Jaeger. I could add another exporter, and I could just replace Jaeger by Elastic APM, or that doesn't exist yet, but let's say Elastic APM or application insights. And if we start this application, oh yeah, by the way, what the application does, maybe you already figured it out, but there is a super complicated for loop here, which counts to 10, and in the do work method, we just print a line and then sleep for 1 second. That's it. Super complicated. So if we, and like I said, Jaeger is already configured here. No, not that. And if we start that, whoops. If we start that, we'll print stuff to the console, like doing the work, and it creates these pens. And if we go to Jaeger, Jaeger is already running locally on my machine. Right. There we go. So this is Jaeger. This is the Jaeger UI, and the service that we use here is the Jaeger test. And if we go to find traces, that's exactly what we created. So this is, as you see, this is the main method, and this is the do work method. And what a surprise, those pens are 1 second long, and the whole stuff is 10.02 seconds. So 0.2 is the overhead of .NET. The other part is the service. Basically, that's it. Oh yeah, and by the way, we can also look at the text. Like there is this sample attribute 42, and that we set in the code somewhere. There we go. So this basically shows up on the UI. Yeah. So let me. So currently, in order for this to work, you need the OpenTelemetry, or either just the OpenTelemetry.api project, or if you also want to configure the export tab and the OpenTelemetry NuGet package, and then the export tab. And we could theoretically just if you want to replace Jaeger, so Jaeger was just the free open source stuff, which is nice. But if you say I want application insights because it's better, then you can just just search for OpenTelemetry export tab, and there is you can, for example, there is one for Prometheus if someone that uses that, or Stackdriver. Zipkin is another visualization tool similar to Jaeger. There are plenty of those. Let's say we want this for application insights. You just put that NuGet package into your project, and then from that point, all you need to do in order to replace your tracing tool is just to say, instead of use Jaeger, say use application insights. So there we go, it shows up, and that's it. How to switch between these systems. Like I said, I talked about this OpenTelemetry collector. There is an exporter for that. Open, yeah, exactly. That's the one. So it says OpenTelemetry exporter to OpenTelemetry collector. So you can, like I said, this OpenTelemetry collector. That's another component that can take these. If we go back to the slides, that's the. So that's basically this component that I talked about previously, and you can run it anywhere, and you can configure that to either put the stuff into Jaeger or Elastic APM or anything like that. So you either you do it directly, store or send the stuff directly to application insights or Jaeger, or you can put this collector in between, and that gives you more flexibility. So that's OpenTelemetry. Now this sounds amazing. Like this is really cool, but be careful, because if you look at the version number here, then you will see 0.20 alpha. So yeah, keep this in mind. So take a look at it. Super useful, very promising, but this is super early stage, and I personally would not use it in production, but hopefully this will become something awesome. Yeah, that's about OpenTelemetry. I mean, there are lots of things to talk about here, but I would say this is not ready yet. Questions to this? Is it helpful for not having vendor locking? Yeah, hopefully it will solve that if it becomes stable. Okay, so I talked about all these stuff that, I showed you how Elastic APM and application insights captures traces. We saw with OpenTelemetry that we manually capture traces, but in the first demos we saw that data was actually automatically captured, like out of the box. Like we saw the outgoing HTTP request, we saw the entity framework core calls. How does that work? So how is this automatic data capturing work? Actually, in the OpenTelemetry sample, I showed you manual tracing, like I captured the span manually, but they also have stuff that captures you things out of the box. For example, they have stuff for ASP.NET Core, and they can automatically capture the incoming calls for you. They also capture the outgoing calls. So the question is, how does this work? And for this, there is a built-in stuff in .NET called Diagnostic Source. This is baked into .NET, and yeah, so this is part of .NET Core, and also .NET Framework, and all this stuff lives in the system.diagnostic source namespace. And the idea is that Microsoft basically created these components for other vendors to gather this telemetry data. That's the idea behind it. Yeah, so it's code instrumentation for production time logging and rich data payloads. It has basically two capabilities, like there are two sides. There is one side that writes the data, and then there is another side that listens to the data. It works with objects, so it's basically structured data. So this is not like logging, but it's like if for example, an outgoing HTTP request happens, and you will get the outgoing HTTP request object. Or when a database call is happening, then you will get the SQL command object, which is super powerful. You can create, you can create metrics based on it, and this is for observability tools. This is super useful. Okay, so let's talk about the first part. Let's talk about how you can instrument code with Diagnostic Source. So how does that work? Okay, so we have here this super complicated method, calculate average, which calculates the average of this any numerical double, and then returns the value. So let's say we want to have diagnostic source for this. We want to emit diagnostic source information when this method is called. All you need to do is that you need a static read-only diagnostic source instance. The reason for this being static is that you don't want to have GC problems when you have multiple instances and you have a listener and you cannot, if it doesn't unsubscribe, then the instance of this class cannot be destroyed by the GC, obviously, because it's still used. So that's why it should be static. And with diagnostic source.write, you can write a diagnostic source information. So what happens here, let me use the laser pointer. So with this diagnostic source write, you have, I told you that this is basically, it works with objects. So it has a key. This is the key of this diagnostic source information. And this is the payload. And this can be anything. So does anyone know what this syntax is? Like, what's this strange stuff there?
Anonymous objects.
Yeah, right, anonymous objects. Exactly, so these are anonymous objects. So what typically happens, and this is what the libraries do, and this is how Microsoft emits these events. So basically they just create a type on the fly, and in this case, this type will have a property called items, and we will point that items to this stuff that comes into a parameter. Theoretically, this could be a normal class. This is just technicality, and this is usually how people use it. There is also one more thing here, which is that you can query whether there is a listener or not. And this is enabled, gives you this information. So if there is no listener for this trace, then you can, and you obviously, there is an allocation here in the method call, so you can save that. So if you use it, always make sure you use this isEnable method. Okay, so that's how you emit diagnostic source information. Now, how can you receive this? There is another side, there is the receiver. All you need to do is that there is a static diagnostic listener, all listeners static property, and with the subscribe method, you can give this method a class that implements iObservable diagnostic listener, and each time there is a component loaded into your application which emits diagnostic source events, this onNext method will be called. So in our case, this was the listener was called my library, and this will show up. And then from that point, you can say, okay, I want to listen to diagnostic source information from this library, and the way you do this is that you implement another class, which implements iObservable key value pair string object. And this also has an onNext method, and in this onNext method, basically you get the real information. So the key, this method will be called when I write the diagnostic source data. So basically there are two cases. This is when the average calculation is started, and what happens here is that with reflection we parse out this items property. The items property is enumerable double. That's where the parameters are, and we just print it to the console. You can do whatever you want with that, and in the other one you can we parse out the result. That's the property that we are storing, and we print it to the console. Yeah, I have this. We can skip that one. Okay, so I'm not showing this just to save time. I'm skipping this one. We could debug through that. Doesn't really matter. Now, why am I talking about this? Doesn't make sense to emit these diagnostic source traces when you when you have an average calculation. Yes, but the Microsoft libraries emit this diagnostic source information for you for the telemetry data. So, for example, HTTP, we saw here this calculate entry start and stop. The HTTP client class that you use to make outgoing HTTP request, that does the same for you when you do an outgoing HTTP request. Or Entity Framework Core does exactly the same for you when a database request happens. And for example, also ASP.NET Core does the same for you when a request comes in, or when a request is sent. And for example, in case of the outgoing HTTP web request, it's not that it gives you the start and the stop. So basically, with the start and the stop, you can already measure the duration of the HTTP call, right? So we saw how long those spans are, those outgoing web requests take. This is how we measure that, because we can measure the time between the start and the stop, so we know how long it takes. But not only that, we also have access to the outgoing HTTP client, and we can place an HTTP header, for example, into the outgoing web request. And we saw that the trace parent header gets injected into the outgoing web request call. This is exactly how it happens. So let's debug through a little bit with diagnostic source and HTTP client. So let me show you a demo. Does anyone have a question to this? Or okay. So let's close everything, and let's go to the next sample, which is if you go to the GitHub repository that I showed you, you can debug through this my library stuff if you want. So this is basically that I showed you on the slide. But let's skip that one. Let's move immediately to the HTTP client one. So what we have here is in the main method there is the subscribe call. We will take a look at later what it does. And then after that, all we do is we do an outgoing HTTP request call to my website. That's all the application does. So what this subscribe method does, this is very similar to what we saw when we register Elastic APM or application insights. So there is one method call, and behind the scenes, they basically do something similar to what happens in our subscribe call. And in the subscribe call, what happens is that there is this diagnostic listener, all listeners.subscribe, and we have a class here which basically subscribes to this HTTP handler diagnostic listener. This is the diagnostic source that HTTP client uses, and then we have this HTTP client observer here, and all it does is, first of all, we measure time. So we have a stopwatch here, and when this event comes, we start the stopwatch, and then we stop it when the HTTP request.out request or out message comes in. And in the start, we can parse out the HTTP request message object. And this HTTP request message object has, for example, the HTTP method. It has the request URI, and what it also has is HTTP request. And what it also has is we also have access to the header. So that's where we could inject the header. We don't do that here. Doesn't really matter. And yeah, in the stop, we just stop the stopwatch. And what we also do is that we can parse out the HTTP response message object. That's the real object. That's the response. And it has, for example, a property called status code, which is the status code of the response. So let me just start this and take a look at what happens. Oops. So what we saw is that automatically it captured that this was an HTTP GET. That's my own website, and it also measured the time. It was almost a second. And it also shows you the status code. So that's how application insights or Elastic APM or actually OpenTelemetry has these automatic collections, and they use the same. So that's how this works. Yeah. Any question to this?
Can you also log the memory usage?
Can you log the memory usage? The memory usage of the HTTP call?
Yeah.
Or the memory usage of the application?
Both.
Okay, so the memory usage of the HTTP call, I don't know, but maybe something is on the content. That's an HTTP content. That's a stream, so that has a size. I mean, I don't know, I'm just making this up on the fly. But so if that's stored on the response message, then you can. Yeah. So regarding collecting memory usage. Okay, so let's go back to. We could also do this in application insights, but let's do this in Elastic APM. So there is if you look at a service, there is this matrix here, and the agent. If the application runs, and the problem is that the application is not running there, so if it runs continuously, then you will obviously have data, but let's say we want that for the last 7 hours, that it also shows you the, okay, it doesn't. So anyways, so it basically shows you the memory usage, so when the application runs. So you can collect memory usage, but we don't do this with, we don't and also CPU usage, but we don't do this with diagnostic source. So there are other ways to do this. One is event listener. Other one is just there is actually a process class. Process get current process working set, and also you can the private bytes, you can the private memory size. So that gives you this information. So in order to collect memory usage, you don't really need diagnostic source. Because in order to collect, if you want to have that for the size of the HTTP request, then yes, you need that. But general for the process, you don't really need it. You can get this information somewhere else. Other question? No? Okay. Yeah, so we saw that one. Okay, so we saw that one, yeah, so basically the HTTP client class itself, that sends you this diagnostic information data. It sends actually two pairs of events. There is a system net HTTP request and HTTP response, and then there is this other one, system net HTTP request of start and stop. These ones are deprecated. So yeah, if you debug this stuff, you can find really strange stuff. Basically, these are the old ones; those are deprecated, and these are the new ones that are using my sample application, and those use activity behind the scenes, and we will talk about activity in a moment. So, just to summarize this, so diagnostic source is used by the framework itself. For example, HTTP client uses this, ASP.NET uses this. For example, ASP.NET MVC, when the control level gets triggered, that also sends you a diagnostic source information. Entity framework core does it. There are plenty of Azure libraries that use it. So it's used heavily in the .NET ecosystem. For example, there is also an Elasticsearch .NET client, which also introduced diagnostic source use. So if you use the Elasticsearch .NET client, that also emits diagnostic source information. Question? No? Okay, so last topic. Let's talk a little bit about activity. So activity is basically a layer on top of diagnostic source. It is integrated with diagnostic source, and it also has an ID, and it's hierarchical. So you can create an activity, and you can create a child activity for this activity. And it also has two properties. There is tags and baggage. The tags property is local to the given activity, and if you put something into the baggage property, it will be propagated to child activities. Now, this sounds very similar to these spans and open tracing and all that stuff. Like, why does this exist? So the thing is that this is baked into .NET. So OpenTelemetry, you need to add an extra library, or also for Elastic API, you need to add an extra library. But activity is baked in. So this is, if you do find a project, that's already there. And so basically, what activity does for you is that in the previous sample, we just we manually emitted these diagnostic source events. Activity does it for you out of the box. So the way this works is that you can create an activity. We call this my activity, and with diagnostic with a diagnostic source instance, you can just say start activity, and with that, it will emit you a diagnostic source event, and then you do the work. You can also use the two properties that I talked about. So you can use the baggage and then the tag property, and then you can also load those, and then if you are done, you can just simply call stop activity. So in the previous example, I showed you this manual like diagnostic source .write method. That's not really hard. That's very old school. That's how it worked in like .NET 1.0 or .NET Core 1.0 time. But these days, basically, that's if you look at the source code of HTTP client or any of these components that emit diagnostic source information, those will basically use the activity class and start activities. So and there is also an activity current. That's a static property that gives you always the current activity. And it also has activity also has this current ID property, which basically the ID of the parent activity. That's it. So let's take a look at a demo. My machine is on fire. Okay, so in the first example, I showed you this my library where we calculate the average. In this example, we instrument this with activity. So we don't do diagnostic source.write, but we start an activity in the first line of the method, and then if there is a listener, then we start it, calculate the average, and then we stop it when the method is done. And what we also do here is that we do an outgoing HTTP call, and the outgoing, and like I said, in the previous demo, I showed you that HTTP client also starts an activity. Like it emits diagnostic source information, and it does that with activity. So this activity is going to be the child activity of the activity from the first line of the calculate average method. Okay, and what this HTTP call is that this goes to localhost 500, and for that I prepared this super small application that does nothing but it just says activity.current, and it prints the current activity ID and the parent activity ID. So let's start this. So this is the ASP.NET Core application. Let's just start that, and this is the and obviously in this console application we do nothing but we just call this calculate average method, and we subscribe to the diagnostic source stuff that is emitted by this method, and we print the stuff. Basically, all we do is we print the activity ID. Okay, so let me start this. This is the console application, and what we see here is the following. And I put the ASP.NET Core application below that. We saw that the calculate average methods, calculate average async start has an activity ID which ends with F8. The HTTP call has an activity ID which is this one, and its parent ends with F8. So its parent is actually the ID of the calculate average activity. And then in the ASP.NET Core application, which is another process, we have this ID, and the parent ID of this is F8.1 which is the HTTP request F8.1 from the other process. Okay, so this is a hierarchical activities without having OpenTelemetry or having anything, and this is how it works. So the cool thing about this is that this is baked into .NET. By the way, so in one of my previous demos, I printed you the activity ID, and if you look at this, this is actually a different ID format. So this is not the W3C ID format. So am I lying here, or what's the reason for that? This is the so-called hierarchical activity ID. So if you just look at this, like the dot is so each time it appends a dot and the new ID to it. So you can, just by looking at this, the activity that's the deepest, you can see that the parent is, so that's the ID of this activity, and I know that this is the parent ID, and I know that the this is a different ID format. Now the way this works is that by default, this activity class uses an activity ID format, which is this hierarchical format. But you can actually change that, and you can set the default ID format to activity ID dot W3C. There we go. And with that, if I start it again, that's going to be an ID format that you are already familiar with. There we go, 0, 0, and then that's the trace ID, and that's the parent ID, and that's those are the flags. So this ID, this already looks like the ID format that I showed you. So and this is without any tracing tool, right? So without any tracing tool, you get this information. So all the tracing tool needs to do is basically just hook into that. You already have all the information. Just a fun fact: there is this. There were 3 properties here. There is this activity ID hierarchical. That's default. That's the trace context standard that I showed you. And there is also an unknown. It says an unknown format. Any idea what that does? Any idea? No idea? I showed it to you. It crashes the application. I have no idea what that is. Why that's there? It's just there and it crashes the application. Okay, so just a fun fact. I have no explanation for that one. Don't use it. Okay.
Question.
Yeah.
So does that mean if I now introduce such an activity that it will show up in the elastic trace, for example?
So the question is, will this activity show up in Elastic? Not yet, because you have to manually create a span for it. So I have a slide. I will talk about that, how to do that. But for example, OpenTelemetry has a wrapper for it. You can just wrap the activity and it will start the span for you. So unfortunately, not yet. It would be awesome that an activity would automatically be a span in Elastic APM or in OpenTelemetry. You have to write a little bit of a code for that. Yeah.
But is the idea of this thing more like, okay, if you have something like your library or something that you kind of use this as diagnostics?
Yeah.
And on the other side, for things like this APN Elastic that you are writing, that you hook into this. So that's the general idea why you would want to use this, right? Not that you would use it directly in your application for telemetry.
Yeah, so it totally depends. I have slides on that. So basically the question is how to put data on Elastic APM, or like what. So if you want to put data into Elastic APM, you have to use the API that I introduced previously. That this activity will not show up at this moment. And it would be awesome, and we are thinking about this, but currently it doesn't work. And then okay, so that's how you do it. You already know the API. Basically, you just manually start the transaction. This slide doesn't really matter. Or with that application itself, you could use the telemetry client. But then the question is like, should you use activity or should you use the API of the client of Elastic API? Because you could. So in the previous slide, I started an activity, but you could also do this, right? You could just say agent tracer dot start span or whatever, and you can just create a span. So yeah, that's it. So it totally depends what you want to achieve. So there are pros and cons for basically two of both approaches. So if you use the Elastic APM library directly, then you obviously that's like vendor locking, and you have to add another lookup package. But if you are a library author and you want to emit telemetry data from your library, you can just use activity. And the pro here is that you don't have any dependency, because if you start the .NET Standard library, and if you are a .NET library author, then activity is already there. So yeah, this like you have to decide. So if you are fine with having a dependency, then use the Elastic API or the telemetry client from Application Insights, or OpenTelemetry would be also great here. But like currently this 0.2 library, I'm not sure I will do that. But like long term, that would be a great one. But that's still an external dependency. So if you are a library author and you say, okay, I want minimal dependency, I want no overhead whatsoever, but I want to emit diagnostic source information, then I would say activity is the way to go, because that's super lightweight. It's already baked in, that you already depend on that because the framework already depends on that. So yeah. Yeah.
.NET standard, I guess.
Yes, that's part of .NET standard. I think 2.0, I'm not sure. Yeah, that's part of .NET standard, yes. Other questions? No? Okay, let's wrap this up. Okay, so what did we talk about? Like let's get a quick summary. So we saw how Application Insights and Elastic APM works. We saw how those collect telemetry data from your production systems. We also saw that it correlates logs, traces, and metrics. We also talked about how to manually instrument your code. So if you want to have information about some part of your code, then we talked about manual instrumentation. We saw that you can either do this with these APIs that these tools provide, or you can just use the activity and diagnostic source. Telemetry client is one in Application Insights. Then Elastic APM has this public API, and with those you can reach your activities if you want. And actually, that's what they do for HTTP client or database calls or ASP.NET Core, and that's how they capture these automatically capture this information with just adding a package and writing a single line of code. We talked about distributed tracing. So if you have multiple services, then there is this standard that defines how to propagate the trace context or the trace information. Like I said, this is a W3C standard. And we looked at OpenTelemetry, super promising project if you don't want vendor lock-in, but still want to have tracing or create manual spans in your code. That's it. Couple of like resources and credits. So like there are a couple of awesome presentations there that inspired me to create this. That's my Twitter handle. If you and there is also my website if you have questions, slides and sample code. You already have that, and basically that's it. Thank you. If you have questions, I'm here.
My question is, so
Yeah.
we've mainly talked about logs and tracing.
Yeah.
What about like observing the hardware or the utilization of the containers or whatever I have? So is here also Elastic like the right thing to go with, or do I need to introduce a different observability stack for like Prometheus or whatever?
Yeah, so there in Elastic there are these things called beats, and that's an additional component that you put on the machine, and that will deliver you this data. The agent also collects a couple of metrics. So for example, CPU and memory usage, you always get that you get that for the given process, but you also get that for the whole machine or for the container. So yeah, part of that is captured by the agent. If that's not enough, there are other components that you can basically put into the machine and then collect it for you. Similarly for Application Insights, like Application Insights is also showing a whole bunch of things. For example, there is stuff here called metrics, and it shows you like super useful stuff. First of all, it creates metrics based on the stuff that it creates, like availability, like the duration of the, I don't know what test duration is, but the duration of the request, but it also collects stuff like system runtimes GC metrics, but it also gives you I think system like overall CPU usage. Yeah, process CPU, system runtime CPU hold. Yeah, so either the agent corrects it or